Okay, I'm about to give you the video that I kind of promised you on Wednesday to maybe clear up what went over in class on linear equations. So I'm going to try to share this screen, all right, and get a PowerPoint to come up. Let's see if it's going to work. Yay, it's a good day. Okay, before we talk about the three forms, I'm going to kind of quickly review slope for you because we did it pretty quick in class and it may have been a while since you had slope. Okay, so let's look over here at slope. Slope is a measure of how steep a line is, okay? So if I had a line that went kind of like that, it'd be pretty steep, but if I went like this, now it's going to be steeper, okay? So slope is just a measure of steepness. So it's, like in words, it's rise over run. In a formula, it's y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Now, an easy way to remember that is think about your axis, okay? Remember the axis that goes up and down, the one that rises is your y-axis, and sure enough, the y's are on the top. When you run, you're not going up and down. That's called jumping, okay? When you run, you're going horizontal, so the x-axis is down here. So that's the formula you need to learn for slope. So I just gave you some different situations. I told you to graph the lines going through the points below and then find the slopes of the lines that you drew. So the first pair was 2, 3, and 5, 9. So I just graphed the point 2, 3, and 5, 9, and then I drew the line that went through them. Okay. Now what's the slope of that line? Well, if you're careless like me, you probably are better off labeling one of them x1, y1, and labeling the other x2, y2. That just means the x and y on point 1 and the x and y on point 2. It saves you from making careless errors. So I go down here and always write your formula. Don't try to do it from memory. So the way I have mine labeled, my y sub 2 is 9, and my y on my first point was 3, so I plugged that in. Then x sub 2 was 5, minus x sub 1 is 2. And then, of course, 9 minus 3 is 6, 5 minus 2 is 3, and 6 divided by 3 is 2. So the slope of this line is 2. Now, a lot of times you're going to get fractions. Well, to make 2 a fraction, you put 2 over 1. So that means every time on this line you go up 2, you go to the right 1. So I could go there and then go up 2 and go to the right 1 and see I'd be back there. Go up 2, go to the right 1, I'm back on the line. Now look at this one. Instead of 2, 3, and 5, 9, I use the points 2, 3, and 5, 0. So I still graphed 2, 3, all right? This time I graphed 5, 0, and I drew that line. So again, I labeled x1, y1, and x2, y2, and just plugged into my formula. So the way I have them labeled, I've got my second y is 0 minus my first y is 3. And then my second x was 5 minus my first x was 2. Well, 0 minus 3 is a negative 3. And 5 minus 2 is 3. So a negative divided by a positive was a negative. So I got a negative 1. Now, I want you to notice that this slope is positive and this slope is negative. And then I want you to look at the pictures. Do you see that when you look left to right, when I go left to right, that this line's going up, it's rising. And that slope came out to be positive. Now look at this one. When I look left to right here, my line's not going up, it's going down, it's dropping. And that slope came out to be negative. And that's always going to happen. When you draw the lines, if they're going up, when you look left to right, that means that you better get a positive answer for slope or you've made a mistake. And similarly, when you look left to right, if the line is dropping, you better get a negative slope or you made a mistake. Now, these are kind of your two special cases. I graphed 2, 3, and 5, 3. So notice the y's are the same. When the y's are the same and you graph them, you're going to get a horizontal line. Now, is that line very steep? And then look what you get for your steepness. When I labeled them x1, y1, and x2, y2, y2 minus y1 was 3 minus 3, so that numerator went to 0. Now my denominator, 5 minus 2, was 3. Remember, 0 divided by 3 is 0. So when you have 0 on the top, that's when you get a 0. Okay, and sure enough, this line doesn't have any. It has 0 steepness. It's not steep at all. Now, this line's vertical. Is it steep? It's really, really steep. Okay, and look what happens. When the x coordinates match, like 2, 3, and 2, 5, when you graph those and draw the line, it's going to be vertical. And when you substitute in your formula, when you do y sub 2 minus y sub 1, see I got 2 on the top, But because my x's match, 2 minus 2, I got 0 on the bottom. Now remember, you can't divide by 0. So 2 divided by 0 is undefined, and that's what I want you to write, is undefined. Don't write no slope. Some texts do that, and I think that's confusing because some people get that confused with 0. Because that means that is so steep, there's not a number to tell you how steep it is. So all horizontal lines are going to have a slope of 0. There's no steep, there's 0 steep. And all vertical lines are going to have a slope of undefined. Okay, so you should be able to tell by looking at the picture kind of whether you're going to get a positive answer, a negative answer, 0, or undefined. All right, let's go talk about those 3 forms we talked about this morning. All right, linear equations. They can be general form, they can be slope-intercept form, or they can be point-intercept form. So let's kind of talk about them. The general form is probably the very first way that you learned. Okay, now what that is it's just a number in front of x plus a number in front of y equals another number. So there's an example of a linear equation in general form. If somebody tells you to graph it, then you have to figure out some points on that line. Now we talked about this in class. If you have one point, so you could draw a whole bunch of lines going through that point. But as soon as you draw a second point, now there's only one line that go through both of them. So that's why when you make a t-table, you have to have at least 2 points. Okay, so at least 2 points. All right. So you can put anything in for x you want to. You can put x 0, 100, -4. I let x be 0 because that's easy. When you let x be 0, remember that 2x is going to go away, just leave you 3y is 7. So when you divide both sides by 3, y would come out to be 7/3. So that's how I got 7/3 right there. Okay, so I graph 0, 7/3. So 0 and then 7/3, remember, is about 2 and 2/3. Okay, excuse me, 2 and 2/3. All right, now I went and graphed, all right, 1. I put a 1 in there. All right, we'll see 2 times 1 is going to be 2. So I'm going to have 2 plus 3y is 7. Now, what would happen when I took 2 away from both sides? If I took 2 away from that side, it's going to go out. And if I take 2 away from that, it's going to turn into a 5. So 3y is 5. So when you divide both sides by 3, you get 5/3. So again, that's about 1 and 1/3. All right, so I went over here and I went over 1, then I went up 1 and a little bit more, and I drew my line. That's really all that I needed. Now, let me show you what would have been easier than picking 1. Okay, you don't always have to plug in for x and get y. You can plug in for y and get x. So it was so easy to plug that 0 in here that I decided I think I'm going to plug a 0 in there. See, if I plug 0 in for y, that's going to go out and leave me 2x is 7. So when I divide both sides by 2, x would be 7/2. In other words, 3.5. And see, sure enough, look, that line did go through the point right about 3.5, 0. So really, the intercepts are the easiest ones to graph. And we talked about in class today that an x-intercept is the point where the graph crosses the x-axis. And if you want to find it, let y be 0. So when I plugged in 0 for y, this came out to be my x-intercept. So on this graph, my x-intercept would be the point 7/2, 0. Make sure you write the whole point. All right. Now to get the y-intercept, you let x be 0. So when I plug 0 in for x, I got 7/3. So the y-intercept would be the point 0, 7/3. And so really this point and this point are the quickest ones to use if you want to graph a line. You don't have to, but those are just quick. Okay, so this general form doesn't really do you a whole lot of good, but it's usually the first way that you solve them. Okay, now the other 2 forms are much more helpful, so let's go look at them. This one's probably very familiar to you. Slope-intercept form, y equals mx plus b. Now what that means is if you've got an equation, if you can get y by itself, your slope is going to be sitting right in front of your x. It's going to be the coefficient of your x. And then kind of free of charge, this b is the y coordinate of your y-intercept. Remember, that's where you cross the y-axis. So this is a great form when somebody tells you to find the slope. So like on the previous example, instead of saying graph that, what if somebody said find the slope of that line? Well, see, it's hard to tell the slope from this general form. So I changed it to the slope-intercept form. So remember what that means. It means you get y by itself. So I had to get rid of this 2x. So how do you get rid of this 2x? I subtracted 2x from both sides. So that 2x went out with that 2x and left me 3y. And then I had 7 minus 2x on this side. Now, I don't want anything in front of that y. So how do you get rid of that 3? Well, that's why I divided by 3. But if you divide one thing by 3, you've got to divide everything by 3. So those 3's went out and left you y. Well, 7 divided by 3 won't look any better, neither will 2 divided by 3. So this is the form. Now notice y is by itself. So when y is by itself, your slope is the entire number, not just that number on top, the entire number. Make sure you take that with it. So it's a negative 2/3. Now some of you, rightly so, will be bothered because mine has the x's first and this one doesn't have the x's first. So what you can do is you can change this to that form. In other words, subtraction is the same thing as adding a negative. And then remember, with addition, you can change the order on addition. You can't change the order on subtraction. So when I change it to addition and then I change the order, then I have something in front of x plus another number. So again, the thing in front of the x is a negative 2/3. But you don't have to change the order. If you get y by itself, your slope is sitting right in front of your x. Just don't forget to take the sign with it. Now, let me make sure we're clear about this. This 7/3 is the y part of the y-intercept. So I would know, remember, on the y-intercept, x is 0, and then that's the y part. So I would know that on this graph, this line goes through the graph at the point 0, 7/3. And if you go back and look at your previous slide, that is where we cross the y-axis. So if on a test, if I give you an equation that's a linear equation and I say find the slope, the easiest way to do that is to get y by itself, and then your slope's always going to be sitting right in front of x. So that's the advantage of this form, is when you're finding slope. Now, here's your third form. Your third form is called point-slope equation, and it's y minus y sub 1 equals m times x minus x sub 1. Now, when is that a handy one to do? That's handy if you're told to write the equation of a line. So anytime I'm told to write the equation of a line, I'm going to go use this form right here. And what it tells me is I need two things. That m is my slope, so I'm going to need to know the slope. Do you notice that one pair of x's and y's has a subscript and one doesn't? The pair with the subscript is a point. So that's going to be replaced with numbers. So I need a point. So when you want to write the equation of any line, you need two things, a point and a slope. So look at one like I might give you on your second test. Write the equation of the line that passes through the points 0, 6, and negative 1, 5. So as soon as it says write the equation of the line, I'm going to write down y minus y1 equals m times x minus x sub 1. So anytime it tells me to write the equation of a line, I'm going to write that down there. And as soon as I know slope, I'm going to substitute that in for m. And as soon as I know my point, I'm going to put that in for the x1 and the y1. Okay? So look at what we've got. All right? I need to know two things, a point and a slope. Now, do I know a point? Oh yeah, I got more than enough points. I just need one and I got two, so I got extra points. But I'm missing my slope. I have to know my slope. But remember back on that first slide, we learned how to find slope. Remember, it's y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So I labeled my point. So y2 was negative 5 minus my y1 was 6. And then x2 is a negative 1 minus 0. So a negative 5 minus 6 more is a negative 11 over a negative 1. Well, now remember, a negative divided by a negative is a positive. So now I can fill in my slope. My slope is 11. Now, which point should I use? Okay, I'm going to show you it doesn't matter. Suppose I decided to use this first point, 0, 6. Well, remember, then this is my x1, y1 that I'm going to plug in here. So y minus my y coordinate is 6. My slope, remember, slope is your m. My slope is 11, and then x minus the x part of my point is 0. Now, if they just tell you to write the equation of a line, you can stop and box it right here. I'd be satisfied. Now, look what would happen over here. What if your friend had chosen this other point instead? Well, this is your point you're going to use, so you're going to label that one x1, y1 for this formula. So y minus the y part of your point is a -5. Your slope is 11, and it's x minus, that's not your negative, that's your minus, and your x coordinate is a -1. Now, what's the same thing as minus a negative? Isn't that the same thing as plus a positive? You could stop, so I would take this answer or I would take this answer. Now, you may say, well, they're two different answers. Well, really, they're not. Look what happens if I multiply this out. 11 times x is 11x minus 11 times 0 is 0. Now, how would I get rid of this minus 6? I'd have to add 6 over here, and I'd have to add 6 over here. Well, those 6's go out and leave me y equals this 11x, and then 0 plus 6 is 6. So notice, this is a different, it looks different. That's that slope-intercept form. Well, look what happens if you multiply this one out. Y plus 5, 11 times x is 11x, plus 11 times 1 is 11. Now, if I get y by itself, I subtract 5 over here, so I got to subtract 5 over here. Look what happens when you multiply them out. They're actually the same. That's why a lot of times when you turn to your answer in the back of the book, they're going to put this form. I don't care if you leave those forms, but they put it this form so that regardless of which point you used, you can check to see if you got the right answer. So anytime they tell you to write the equation of a line, you need two things, a point and a slope, and you're going to plug into this formula right there. Okay? Now let me show you one more thing just to make sure that it doesn't bother you when you start your homework. Does it make sense to you that if lines were parallel, they'd have the same slope? Remember what lines are parallel, so that means that that one and that one look like they're parallel. So they would be kind of angled the same, so their steepness would be the same. So if I guarantee you the lines are parallel, you know they have the same slope. Now remember, perpendicular lines look like this. Remember, you get right angles. Well, see, their slopes aren't going to be the same, but there is a relationship. They're opposites. So if one's positive, the other's going to be negative, and reciprocal means you flip it. So what if I gave you this on a test? Write the equation of a line that passes through the point 1, 4 and is parallel to the line -2x plus 7y is 9. So as soon as it says write the equation of a line, remember I'm going to write on my paper y minus y1 equals m times x minus x1. That's the best form when you have to write the equation of a line. And I need two things. I need a point and I need a slope. Well, look, they gave me a point, so that's no problem, but oops, I'm missing my slope. Now, why would they tell me that my line is parallel to that line? Remember what we just said. Parallel lines have the same slope. So if I could figure out the slope of this line, I would know what my slope is because they match. Well, remember what we talked about a minute ago. If you want to know what the slope is, the easiest way to know what the slope is to get this y by itself, and then your slope is sitting in front of your x. So that's what I did. I decided I was going to isolate this y. So I've got to get rid of this -2x. Well, how do you get rid of a -2x? Don't you have to add 2x to both sides? Well, those 2x's go out and leave me 7y. Now here, instead of putting 9 plus 2x, I just reversed it and put 2x plus 9. Can't you change the order on addition? You don't have to, okay? I want just y, so if I divide this side by 7, I got to divide every side by 7. So that's y is 2x over 7 plus 9 over 7. Now y is by itself, so your slope is what's sitting in front of your x. So my slope is 2/7. So now I know my slope is 2/7. So I plug, this is my x1 and my y1, my x1 and my y1, and that's my m, that's my slope. So that's what I did. I plugged my y in for y1 on my point. I plugged my x in for my x1 and plugged in my slope. Now, like I said, you can stop right here if you want to. But in the back of the book, they're probably going to multiply it out and put this answer. But on a test, I would take either one. Now, I want to make sure we're clear about something. What would have happened if it had said, write the equation of a line that passes through that point, but if it said perpendicular instead of saying parallel? Now, my work would not have been any different. I still would have needed a point and a slope. So I'm still missing my slope. Well, why would I tell you that my line is perpendicular to this one? Why does that help? Because remember, if you know this slope of this line, you can do the opposite reciprocal and get your slope. So I would do the same work. I would try to get y by itself and figure out, well, the slope of that line is 2/7. So that line has a slope of 2/7. But now my line's not parallel, so it's not going to match. It's going to be the opposite reciprocal. So if this slope is positive, mine's going to be negative. If this slope had been negative, mine would be positive. So I changed the sign and then I turned it upside down. Instead of 2/7, I put 7/2. So now, instead of having 2/7 right there, I have a -7/2. And again, that would be your answer. If you wanted to multiply it out, that would be a good answer too. So when they're parallel, their slopes are the same. When they're perpendicular, they're opposite reciprocals. So I hope that helps you with your homework. Try it, but remember, this material is not for test 1. This material is for test 2. Okay? So go try that homework and let me know if you have